Hey folks, how you doing?
Well, it's bucking hard, but I'm still on.
Well, you hang right in there, Don.
Yeah, I'm just waiting for the whistle, collect my money.
Sounds good. Hey Mark, how's things down under? Can you hear me, Mark?
Hey, good morning. Can you hear me?
I see you there.
How's the summer in Denver?
It's been hot in the now it was up in the over 100 last week. That's
Right.
Fahrenheit. But
Good thing that it's Fahrenheit.
Yeah.
but you know, it's typical summer in Colorado.
Yeah, you get hot summers and cold winters by the sound of it.
Or not as cold as North Dakota or Montana, for instance. Those are places that really get cold.
We have 90 degrees here.
Really, wow.
Yeah.
And there's Floyd's got an antenna for the birds.
Boy, I'll say, what a shot.
Yeah,
Oh, my Lord.
That's what happens when they come home to roost.
yeah, a lot of roosting going on there.
Boy, oh boy. What happens if you put about a kilowatt on that?
You get a lot of fried bird food.
Do they even notice it?
If they're pigeons, it's not too bad, but
You don't want blackbird pie?
oh,
Wonder if they would learn not to get on there if you hit them with a few hundred watts every now and again.
they'd have to perch on two polarities, so or to go through them. So
I might get a little tingle. If they have sharp beaks. they might get a little tingle from the beak.
Yeah.
On the other hand, it might enhance the directivity a little bit, or the bandwidth anyway.
Yeah, bandwidth would probably improve.
Uh,
Is Bill Miller still gallivanting over there on the west slope?
Yes, he is. He said doesn't have very good yeah, internet wherever he is. So he's not going to
Sure, he
be.
doesn't.
He is going to be able to get in tonight, but we'll see. Well, we don't have a large crowd tonight, but we got some interesting guys on, so it should help. And I'm sure more people. There's Myron getting on. Good to see him on. All righty, well, let's get rolling here. Let me make sure we're recording. See. All right, I guess we are recording. So thank you very much for showing up, folks. Glad to see everybody on. And we've been doing a lot of stuff at DSES in the last month and a half. And I figured we better have an engineering meeting while we don't want to have too many things outstanding that you guys don't know about. So I figured we'd share. So let me share with you the agenda. I can. All right. So there's the agenda for tonight. We're going to talk about Diane 2.0. I don't know. I didn't see. I didn't see Alex on there, so hopefully he'll be on here soon. And let's see. Are you on? There you go. And we got some talk about a baridium, rubidium. Why is it a BR? It should be RB. Golly.
Rubidium.
I'm getting dyslectic. It's a rubidium clock being donated, and I could talk about that. We got a fiber installation update. Roger was there when the folks came along and did some installation work for us. Ray and Dan can talk about the pulsar receiving improvements. And I can talk a little bit about our weedorama, as I call it, or the weeds, the takeover of the weeds. And we can have some general discussion after that if you like. So let's just see here. I can't see everybody on at the same time here, so I gotta take my thing out here. I guess he's not maybe he's not hooked up yet. But I was looking for Alex because Alex has a presentation he was going to make for us. And anyway, well, we'll just pass him for a second here. And let me get into the rubidium clock for a minute here. Let me just stop the share and let's see if I can put the other one on here. There it is right there. Okay, so this is This is something that was, is being donated to, Deep Space Exploration Society. And through a friend of, Rick Hambley's, K0GD. By the way, he can't make it tonight because it's his birthday and his granddaughter is visiting for his birthday. So he's, got a little, birthday party going. So that's, you guys can, wish him a happy birthday. I don't know how old he is, but I'm sure he's up in the, same category as me and a few of the other guys here. But anyway, this is
Paul, are we
the,
supposed to be seeing a picture other than your agenda?
I'm sorry, did I not do that? Oh, here we go. I got to stop share. I clicked on it, but it didn't do anything. Thank you for noticing. It's a good way to find out if anybody's listening. Can you see something now?
Yes.
Ah, good. I pushed the right button this time. Thank you for helping me there. Yeah, so this is an example of what we're going to be getting. There's a, it's like the rubidium clock down here in the bottom. And
You just
Here's-
unshared it.
what?
Yeah, it's gone again. You clicked X in the upper right-hand corner and it went away.
Okay, can you see it now? Oh, yeah,
Nope.
I see. Sorry. This is why is this happening to me?
Where are the hands on that clock?
It's just digital clock, I'm afraid.
Where do you wind it up?
At the back. Yeah, anyway, you can see there's the, you can see it now, right?
Yep.
Okay, good. I'm just closing these pictures. I thought I was. And it seems like it stops all the time every time I do
Gone
it.
again.
That's weird, yeah. Anyway, I guess I gotta do this in a different way next time. Anyway, there's a close-up of it. This clock is good for 7 times 10 to the 12th, or 10 to the minus 12, in terms of accuracy. I was looking up the specs earlier. So it should be pretty good for anything that we're working on as far as deep space is concerned, and keep us on frequency for our recordings. But so the trick to this donation is the fact that it's the equipment is located in San Diego, and we have to get it from San Diego to Haswell. So I think at some point here, unless somebody else volunteers, I guess I'm going to go down there with Rick, fly there, and maybe rent a vehicle and bring it back. This equipment, when it was new, is about $35,000. So depending on what features it has with it, but it's a pretty darn good clock, and it'll suit our purposes and will fit right into our rack. So that'll be.
Paul,
Yes, Doug.
what, how much does it weigh? What are the dimensions? Looks like a standard rack size.
Well, it's not just that, it's the rack with
The whole rack.
in it.
So-
But this weighs 110 pounds by itself.
So we need the rack and the 110-pound piece. So would it fit in a standard SUV?
It would fit in a what do you call it? A Chevy Suburban.
Okay.
You put the seats down in the back, and or a Lincoln Navigator or any of those kind of things. So that's kind of where our thought was, to go with something a little bit larger to carry it and drive the 1,000 some odd miles from
Yeah.
there to Haswell.
I don't have that vehicle, but I'd be, if we could arrange it sometime in August or September, I could join or participate.
Well, if you like that kind of
Of
stuff.
the other,
I do. Yeah. I I like,
you
I like that trip.
You want to see America, huh?
I
of the
would
other,
really enjoy that. Yes.
the other possibility is that, oh, wait, never mind, it wouldn't work. Sorry.
Yeah, we looked at a lot of options there. I was trying desperately to try to get, some other way of doing it. But he said he won't let it get shipped, with like FedEx or something,
No.
because it would probably not work when it gets here. So that's why we're going to be driving it.
Yeah, it's tricky.
Yeah,
It'll have
well,
to come out of the rack anyway and be laid flat.
yeah,
The
it's
rack,
like,
the rack has to be laid flat, and the thing should probably go on the front seat.
Mhm.
Or on the back seat or something.
we'll find a place for it.
Yeah,
We'll,
Strap down.
they are, those instruments of that era are prone to vibration failure,
mhm.
unfortunately. They're
This
just old.
this one's supposed to be in excellent condition, so
Great.
we'll
They're hard to come by.
yeah, I know. I was looking online, and yeah, there's very few of them for sale.
The HPs, yeah.
Yeah, because they're supposed to
There's
be
other varieties, but the HPs are gold.
the best of the best. So
Yep.
anyway, so
Good.
that'll be a great addition to our
If you,
astronomy plans as
if you
well
want,
as.
if you want some more particulars, go to leapsecond.com.
Mhm.
That's Tom Van Back's website, and it'll have a good analysis of it, pictures, and I think there's also manuals
Yes, I saw
available.
it online. I was going to download the manual, but it
Yeah,
would be for someone with my brains, I don't think I would understand it. So, but I'd like to print it out, put it in a binder, and have it as well. So whoever's going to be managing this will have a reference for us.
absolutely necessary. It's
Yes,
going to take some tending.
I'm sure there's some of that for sure. Okay. Anyway, that was my little addition there. Let me see if I can.
Do those units have a lifetime of operation?
They do.
Yeah, they,
Go ahead.
yeah, but it's probably the rubidiums last a little longer than the cesiums. It ought to be good for quite a while if it's in good shape.
Well, guys, I'm down in San Diego, but there's no way I could, I could shuttle that up to you guys.
Oh,
Sorry.
come on, Adrian.
There's one possibility. Sometimes they like to move those large cars from one point to another,
Oh,
and they will cut you a good deal if you're going to go one way.
Yeah, well,
So if you went one way from San Diego, it's going the wrong direction from California, unfortunately. But you could try to see if they want to bring it to Colorado somewhere and then fly home. And you might get quite a good deal on bringing the large car, or
SUV.
from San Diego to Colorado. It's a question that's easily answered from the companies, Enterprise or any of the rest of them. You got one
Yeah.
you want delivered? We can do that.
good idea. Good idea.
Thank you, Don.
Yep.
Appreciate it. Okay, let's
You
stop
might
that.
even pay him.
All right, let me move along here. Let me close this off and go back to our agenda one more time. And so here's the agenda again. And I see right now we have, I don't know how he does it. He's got his picture kind of surrounded by by diamonds or something, or lights. Alex, you always surprise me. Anyway, perhaps Alex, you want to go through your explanation and give us an update on our friend Diane and what's coming along there in your super lab that you keep building stuff in.
Yeah, good evening. Do you hear me okay?
That's perfect, man. 5 by 5.
All right. Let me see. I'm gonna try to share it. So I'm gonna request share. Share screen one. Let me see if does anyone sees the screen?
Yeah, a lot of Swiss cheese.
Big moon.
All right. Well, Diane 2. So, sorry, I just had little time to get all this crafted. Thanks to Paul.
He always does his best work when I.
All right, so I didn't expect, but I had no choice. So here we are, Diane 2.0. So what is Diane 2.0? Well, it's, as you know already, the Diane package we use successfully numerous times during contests and open house and etc. So the Diane 2.0 is actually an improved version of the previous package. Basically lessons learned, something that I personally wanted to improve and something we encountered during the operation and use of the system. Because when you initially design, you don't know what's going to happen until you try it. So, and that was a perfect opportunity for us to try it and see what we need to do the best. After EVE 25, we had perfect time to kind of focus on the end package. So I had opportunity to rebuild it. So basically building from scratch, but the idea was to keep the same package, to keep the same box, and keep the interfaces and existed infrastructure that we built for EVE 25/26 projects. So as one said, it's all-in-one system. That means everything in one package, and this package supersedes the previous
Toothbrush. You need a
And-
toothbrush.
It's not exist anymore. So it's a brand new system. Also, this system has the flexibility, more flexibility. I was able to improve performance as well, and I added remote capabilities, which was what we found before that is actually very convenient for our use. And as a previous package, this package is ideal for EME contests and as well daily operations. So anyone want to use it. So what's actually new in this particular system is 3 main parts. I kind of separated, and I'm going to talk about each one separately. So remote control and telemetry, similar to EVE 25 project system. So it adds more actually data points to see in real time than the previous. Whoever operated the previous Diane package will know that we had to have the camera, we have to adjust the camera, and camera has a lot of issues in the past. So I wanted to totally get rid of that and get to the another level. So RX performance, I noticed that before we kind of were losing a couple dBs on receive. Maybe it wasn't negligible because of our antenna gain, but when you redesign the system, you want to kind of squeeze all performance if it's possible. So in this case, I no longer have LNA inside. The LNA is outside, and if you remember the feed that we use for EVE 25, it actually has built-in LNA. So I built the infrastructure, the connectors, the connections that utilize the same system. So basically, whatever you're going to go with, it's going to be the same connections. And the third one is RF and EMI susceptibility. Once again, whoever previously operated and used the system noticed that sometimes we encounter some issues. such like susceptibility. It was hard to identify the root cause of it, but we kind of pointed and agreed that it's possible when the elevation motor kicks on and it generates the noise, because all previous issues that we saw were associated with this event. So, but for me, it was important to kind of improve the overall EMI RFI profile of the system. So make sure we no longer have a susceptibility. That needs to be yet verified. All right, let's start in detail. Remote capabilities. What were the remote capabilities? The similar screen that some of you already know and have seen it for EVE25. It's very convenient. I use this on a daily basis, by the way, because that's not my first system. I built numerous systems using the same system. So it's really reliable and very inconvenient and flexible. So you can add as many telemetry as you want. Points. In our case, it's going to be the real-time DC voltage and current, which is important to verify how system is healthy or not. Temperature, I believe I have in Diane 6 temperature sensors. Also possibility to use external sensors to measure the temperature on different points, perhaps around the feed or hub, anywhere you want it. Also measure the RF power, which includes reflected power and the forward power and reverse power. Digital input output statuses. Basically, this is the help system. So let's see if I'm locked, if I'm transmitting from the transmitter. So those important data points that give you the helpful information to troubleshoot or identify if the system performs 100% or something as malfunction. And all of that. Previously, we did not have that. So right now, I can verify every single part of the system performance using that digital statuses. Analog data readings, basically, you can read anything that comes to the system between 0 and 5 volts. Basically, you can measure any analog systems. In this case, we're using for RF power, let's say, and can be also used to use for the readings of any sensors that provide analog outputs. Basically, this is just what the capability includes. And remote control. Basically, I have 6 switches in there which I can remotely control using the fiber optic. And that can be used for everything, turn on and off. Let's say put the camera in there and on and off, or any other devices. Or let's say we're going to put the platform that's going to adjust the focus for the feed. We can remotely control from the same package. As well, that can be done actually from EVE25. All right, RX performance, receive performance. To improve the dynamic range, will lower the noise figure, which kind of affects the overall receive losses. I had to move LNA as close as possible to the feed, which is the RX port. That by itself already saves about 1 or 2 dB, and 1 or 2 dB is kind of significant for EME actually, and as well improve the temperature of the overall the system. So it's not a big change, but it's just a convenient when you redesign the system. Susceptibility. For this case, based on information and previous tests that I've conducted there, I've concluded that the entire sub chassis needs to be redesigned. So I had to design the sub module, which includes all systems all in one, basically, and all-in-one into the box, the interface with all these external connections. So, and if we need to remove the sub module, it needs to be easily removable. It's kind of a little bit a hard task to make everything look pretty, everything fully be functional, plus it also provide flexibility for maintenance if they need to, because there are devices that can be potentially damaged, and that's why we don't want to rebuild the system just because of removing one of those items. So it was so I decided to build the subsystem that everything attached. You'll see later on the pictures. Once again, that yet to need to be tested and verified performance, but my assumption was the base of my knowledge and understanding that would significantly improve the profile if we still have the same issue. And other improvements include that this particular package compared to previous package has the fiber optic connection. So everything is controlled with fiber optic except PTT. I could add a PTT line, but I found that with adding PTT line into the fiber optic causing a delay. Causing delay around 20 to 30 milliseconds additional, which sequencer should be adjusted to that. In this particular package, I did adjust the sequencer to maximum possible, which 99 millisecond, according to CUNY transverter. But I didn't want to risk to add another delay, so I ran this physical line for PTT like we used to. But once again, in the future, we can always add the PTT into the fiber optic to have 100% remote switching. Well, it looks like this. Whoever previously has seen it, kind of see a lot of similar output inputs and connectors and look, but except a couple of things that I added LAN connection. I added fiber optic. So what we can do, if we use locally with the portable setup, we can actually run LAN, the internet line, 100 megabit per second, no problem. If you're not far from the computer, it's for testing purposes, for maintenance and all that. You don't really need to run the fiber. But if you're far away, like say in the feed, you can use a fiber and run usually like we use the same standard connector that we have currently at the hub, and everything else is pretty much same on this side. The other side, I added a few other things, such like external temperature sensor, so we can connect up to 3 extra temperature sensors outside to do some measurement, science, whatever. And we'll also have spare extra SMA connectors for future improvement. We do have siren, so I added the siren, which is important for, I did not mention that this particular package also has protection. So in a program, view protection in there, so that indicates the high SWR and high reflected power, high temperature, and temperature specialized and on the SSPA itself, the amplifier, or it can be just the output. So it depends what the cause of the problem and not functioning properly. Let's say fans or something else, that each sensor will give you the different readings, and the protection circuit operates individually for each temperature sensor. So this is what I mentioned before. It's a sub module. It's basically sub chassis. Previously, what we had in Diane, we had different parts assembled in different compartments and connected to each other. In this case, everything connected to the common chassis, everything on the same. And as you can see, there's a bunch of ferrites, mainly on the analog lines and digital control lines, to prevent any possible internal RFI issues. I've been using this for years, never had a problem, so it should work here as well. There is a fiber optic conversion and some telemetry module, repam, and on the bottom we have the RF portion, which is transferred itself, the control, and the transmit module. This is the required external connections for the Diane 2.0, which, as we had before, 10 megahertz reference. I could once again I could add this internally, but since we're looking to install the permanent rubidium, and rubidium would be inside the shack, so it would be beneficial to supply external to all our equipment, and except specific feeds that only for receive. But in this particular case, we're looking forward for EME. It's better to supply external. So that's why I have a provision to supply external. So we need to have external clock, 10 megahertz for frequency stability. The IF line that used to be did not change. It's still 28 megahertz since we controlling it remotely. In the future, it could be converted to the SDR with the direct sampling, and also controlled through the fiber optic. But that wasn't the option for this one. So in the future, we can expand, but not for this particular case. PTT line, as well as I mentioned before, that needs to be controlled separately. So this is basically internal system diagram, which is included inside the package. So if I'm not available or I'm not there, and people who qualify can easily read and understand which system, which sub-module, which module connected to what, and what the external interfaces are wired to. So it would be easy to navigate. It's a lot of connection, a lot of things in there, but you know, I throw this just here. Just characteristics what we're looking from Diane 2.0. I tested an uncold, let's say in a winter time, when it's cold and ambient temperature is below 10 degrees Celsius. We can run up to 400 watts. And if we have a normal duty cycle, the power will stay around 350 watts. If it's now the summertime, the average power would be around 300 watts. But 300 watts and 380, it's not a big difference. Wouldn't cause any, but it's all basically the temperature, internal temperature. I try to maximize the airflow, and that's why I have a sensors, temperature sensors around to monitor that. But I've tested in Arizona, which was super hot. So I was able to transmit around about 5 sequences before I hit the protection where ambient temperatures are 100 degrees. But I don't think the 100 degrees would be the case for Colorado, but you never know, just FYI. The noise figure for receive nominal, it was not verified. I did tested the LNA, so I know the LNA provides 0.3 dB, but adding some losses in form of cables will add that number up. The total system is 1.5, which is total acceptable for EME system. It uses regular 110, 15 amps, and we have plenty of those on the hub. The DC power maximum current draw is 32 amps, in average about 30. The DC-DC conversion is about 12 volts, is all built in. Input-output interfaces, you can use internet or you can use fiber optic. Same fiber optic cable we already have. 10 megahertz is a coax cable, SMA, and external connection. Frequency stability, it's better than 0.5 ppm using the GPS system. So if you get as rubidium, that's going to reduce the noise of the phase noise, will improve the receive. The maximum operation ambient temperature where I've tested 122, because in this case, the system become basically, and you cannot use it because it's not enough airflow to cool down the system. You know, we all know about deficiencies. Unfortunately, we're not 100%, so we're about 80%. So 50 degrees is the maximum ambient temperature for use it. So in case if we have a hub does not have airflow inside the hub, and it's kind of trapped hot air, and it reaches 50 degrees, the system will be shut down automatically. So I use just a remote interface, and as default 1200 based what Roger provided me, but the IP address can be changed at any time. So basically, that's all we have. Well, and what's left? It basically is test the new system. So whatever
Alex,
available.
quick question, Alex. What's the IF bandwidth?
IF bandwidth, it's basically depend on the transporter. So I believe it's 5 megahertz.
Okay, thanks.
I have to verify that. Unlike SDR, SDR has a lot more bandwidth because we're using transporter, and that's why we're kind of limited to it.
Yep. All right, thanks.
Well, that's pretty much what I had. And then any questions, anything, please let me know.
Any questions for Alex? No, well, looks pretty cool. I can hardly wait to test it. So maybe in August we can find a weekend that you can come on down and we can put it in there. I know Dan is going to be doing some work with his scan of the Milky Way. And anyway, I'll let Dan talk about that here in a second. But in the meantime, I'll thank you very much, Alex. And going back to, let's see, how do I go back? I'm going to replace the current share with, okay, so this is our agenda again. And so next one is the fiber installation. And Roger, I don't think Bill's on. But maybe Roger can give us a kind of a blow by blow on what happened down there, because we haven't really talked about how the fiber installation went a couple of weeks ago. So with that, I'm gonna let Roger do some talking here.
Okay, and unfortunately, all you're gonna do is get talking because I, don't really have any pictures. I didn't know that Bill had a few pictures. He has them up in the Dropbox that everyone should be able to get to. But June, I think it was June 24th. The folks from ES Tech showed up to run fiber, and Bill was able to quickly negotiate actually running two fibers. From when they were burying the fiber out to the road, they actually buried a second fiber. So we have two fibers coming into the building. One fiber goes directly to the road. The other fiber goes to the road, but it has I think it's approximately a 100-foot loop of extra fiber, which can make it into the bunker. So giving us access for a fiber from the bunker to the building as well as a bunker to the road. So if we've got, if we want to put a camera out at the road or something like that, we have that capability now as well. As an aside, I want to mention that if you get a brush hog out there, be careful. I think that 100 feet or so, it's probably a little bit more than 100 feet of fiber is coiled up somewhere near the bunker, and we don't want to run a brush hog over that. But so the fiber is physically installed, and it hasn't been hooked up. I do not know. Paul, do you have any information on ES Tech when they're thinking of actually activating that fiber?
No, I haven't so far. I haven't spoken to them since the installation, but I will. Actually, I did go down there. I stopped by and I spoke to the engineering manager as I was driving down to Haswell, and went in there and thanked him very much for all the work they had done, plus the additional help as far as the fiber. Question for you: do you know if is this in terms of fiber? Is it a single fiber, or is it a pair, like one transmit receive sort of thing that they're installing, Roger?
I actually don't know. Bill was kind of spearheading the fiber installation. I was off working on the on that scintillation moving that scintillation
Right.
experiment. So I wasn't paying a lot of attention. Yeah, so we have to figure out what we've got. But no matter what we've got there, we should be able to use it.
Okay, that's great. Yeah, either way. Also, too, just a general question: does anybody who's on right now know how to put a connector on the end of a piece of fiber? We had two pieces of fiber running up to the feed, and one of them got loose in a sandstorm, and the wind was so strong it ripped the connector off the end of the piece of fiber. So we've got a piece of fiber up there without anything on it, and I've never tried to put I've never tried to install a piece of connector on a fiber. Anybody had any experience with that?
IBM sent me to school and taught me how to do it, and then I promptly forgot. It's been about 30 years ago.
Right.
It's difficult and calls for special tools.
Right.
You do have to have the
So
right
you'll have
equipment.
to
Yeah.
you'll have to find somebody that can do it. which may
Okay.
not be easy because of the location. But
Right. Well, I looked on eBay and you can get the tools for about $120 or something with, but
can you now? Well, make sure it's for the right fiber.
it's for a kit.
And well, I know, but the problem is there's all kinds of different fibers.
There's a lot of
Un-
different kinds.
Unfortunately, it's not totally standardized. So
Right.
you have to you have to find out which fiber you've got. And then you need the cutting tools and the polishing tools and staking and all that stuff.
Hmm.
So all of that actually included in one machine. So basically like a small computer, and then you just to choose which fiber you have and what connector you want to weld. And the just machine does everything and does all calculation, does all precise power need to apply. It's basically like you're putting two things together, press the button and weld that. So basically it does all in all in one machine. So there is no much thinking involved and not much experience needed for that. It's nowadays is very driven by the electronics. You choose from the list which connector you have, which we know, and what type of the diameter of the fiber optic is, how many and then all of that. But those machines cost money, obviously. So, but they're a cheaper solution. But yes, for cheaper solution, you need to know what you're doing.
Right. Well, maybe I'll talk to ES Technology. Maybe they can help us if they want
Yeah,
to.
they might be able to do it.
Yeah, you can
Maybe-
reach out those fiber optic guys that servicing our internet in there. They might know that. They might gonna help you at no charge.
Do you have the connector, Paul?
No, but we can buy those.
No, I mean, but do you have the one that came off it?
No, it's somewhere in about 2 fields over.
Yeah, those connectors are not for reuse. You just do it
No,
once
but
and
you
that's
have,
it.
no, it's not
You could
that. It's
identify it.
Oh,
Just to
there's
identify it.
another. Well,
you
yeah,
got the other end. You can use the other end to
yeah,
identify what connector you need,
yeah.
and that should tell you the rest of it.
They're in the building. Yeah, we've got 2 fibers
Yeah.
with connectors there, and there's 1 fiber at the top with a connector and 1 without. So we just have to. It's a good thing we ran two fibers anyway.
Yeah,
But just because it was not cheap to do it, but we got it all the way up there.
Yeah, I think if we bring in the fiber into the bunker, or the 2 fibers into the bunker, perhaps when ES Tech is out there, just like we were able to buy the cable that could be buried from them, we can probably pay them to just terminate those ends for us, to give us some kind of standard connection that we can then interface to.
Yep, exactly. Well, whatever interfaces to that switch that you've got down there in the bunker. I saw it yesterday or last
Mhm.
week. They got
Yep.
a big switch, very heavy.
Yes.
And just FYI, I checked how much the connector costs because I know what the type of connector is. So you can buy a dozen connectors for $5.
Yeah.
So those are
That's-
cheap.
That's good. Well, we're gonna slowly drag these guys in, suck them into our environment so they start doing things for us. I mean, so far it's been great. They got a big roll of the fiber at the road, and we can put a camera up on top of the power pole that was left over from before, and we can run. There's actually 2 wires in the fiber, I think. So we could run power out there to power a camera, or we can simply use the reverse on the wires that are up there right now that were used before for the power that came into the building.
There's already power out at that pole.
Yeah, so we may be able to use that. Anyway, whatever, we can have a nice camera there. We can have a nice gate that opens and closes, all that kind of great stuff. But in the meantime, we just have to work on it piece by piece. So
Yeah, just keep in mind, if you get a brush hog out there, don't chop
Yeah.
up our fiber.
I think we're going to probably stay away from there with the brush hog, just in general, because there's not really it's not as bad as around the building and the parking lots and everything like that. Yeah, I'll have to show you a picture of that when we get to that point. It's amazing. I think Myron said he hasn't seen something like this for years, as thick as this stuff is. So, and I sprayed it with extra strength bush killer last weekend. I'm still alive, but and so is the greenery. So I don't know what we're going to do next, but we'll have to see. Okay, let's unless there's some more questions on the fiber.
Yeah, bottom line on the fiber is that physically we are good to go. Bill was able to actually get what we needed done with that buried fiber, and we just have to physically hook things up now.
Yeah, and that's commercial fiber we got now, and it's armored and everything else. So it's the best we could get, and it's really cheap, like 30 cents a foot or something for this commercial fiber. So we got their special deal. Anyway, it was good that Bill stepped into that really well. Okay, so here's the agenda again. So Ray, I don't know if Ray's on. I saw Dan on there. Dan, do you want to talk about the pulsar and what we've been doing with it?
Yeah,
Dan?
let me give you a quick update.
Is that the crab?
Actually, that is the crab. That's the Crab Nebula, and right in the center is the Crab Pulsar, which is, there's only like about 3 pulsars that you actually can see the visible star, because most of the pulsars are, you can't see them in optical, but this one you can. So this is actually an image from NASA that combines Hubble visible with Chandra X-ray. So yeah, we'll talk about that in a minute. So on Friday, July 11th, Rick, Ray, and myself spent some time working on pulsars. And some of this will be a little bit of review. And if I go too fast, let me know. But some of you might be new to pulsars. So they're neutron stars, rapidly rotating neutron stars. They have extreme magnetic fields on them. A neutron star is the leftover crushed core from a supernova explosion of a star that was roughly 10 to 25 solar masses. If the star was bigger than that, it'd be a black hole. So a neutron star is really the last stop before a black hole. They're exotic and poorly understood. They do emit beams of electromagnetic radiation out of their magnetic poles, like shown in the animation there. The pulse timing is very consistent. So you might have read that they make very good clocks. They're using pulsar clocks to search for gravitational waves. The pulses themselves are dispersed by the ISM, which is the interstellar matter. And the ISM, basically, you can think of, there's a column of space between us and the pulsar, and there's free electrons in it. So space is not vacuum. There's these electrons in there. The density of the electrons between us and the pulsar determine how much dispersion the pulse goes through. Dispersion means the pulse gets smeared out. And what that means is the higher frequencies arrive just slightly before the lower frequencies. In particular, this pulsar B0329 plus 54 is we call it our reference pulsar because it's always up. It's circumpolar, and it's the brightest pulsar in the northern hemisphere. So we always start with it. We've detected it many, many times. We know some of its characteristics. Its dispersion measure is 26.7, and again, that's the measure of how many electron density. The distance, it's about 5,000 light years away, off towards the Perseus arm. Just a second. I guess it's getting windy outside. So it's off towards the Perseus arm, about 5,000 light years away. The S400 and S1400 are the flux. These are the published values from the Australia Telescope National Facility. So it's 1,500 millijanskis at 400 megahertz. At 1,400, which is what we're doing here, we did L-band, it's 203. The period is just a little less than a second, it's 0.07 seconds. And the surface magnetism measured in Gauss is estimated to be 10 to the plus 12th, just a huge magnetic field on it. So earlier we put out a little paper about the differences between the clones. So we're kind of continuing the clone wars. This will be part 2. Earlier we did lab tests. Now we're doing a field comparison of the EDIS B210 with the HamGeek B210. And so we did back-to-back 10-minute pulsar data collections with the 1420 feed. The next time we do want to do simultaneous, so we'll split the signal, do simultaneous collections and see that. But this was an interesting result. So the first test is the folding. On the left is the EDIS white one, and on the right is the HamGeek black SDR. And you can see that they're quite similar, nearly identical. It's very hard to see here, but a key value is the reduced chi-square. That's a measure of the strength of the signal. The clone actually did better, but one reason it did a little bit better is because we ran the white one first, and it actually, these little notches here, we caught this pulsar in the act of mode switching. So some pulsars, the pulse is actually bimodal, meaning it has a trailing edge and a leading edge, and they switch back and forth. And so that's what's going on there. And so that's going to affect how much power is under the curve. But we've seen that before. We've seen the mode switching. So in this, for the folding, both SDRs are identical, and they both have the same problem. So this on the left is the phase time plot, and you can see the signal all the way through. This middle one is the phase frequency plot, and frequency here in the middle is 1420. So we did 36 megahertz. We did from 1402 to 1438. But we only have signal in the bottom half. The upper half of the frequency band, we really didn't get much. So, but they both did identical to that. So I don't think it's an SDR problem. Next, I'll just show the dynamic spectrum, which we use a utility called WattUtil to generate the waterfall from the filter bank file that we've collected, and they're nearly identical. If you look closely, you'll see that it looks kind of, you'll see a lot of vertical lines, vertical stripes. That's the frequency channels. In this case, we use 64 frequency channels. So each channel shows up a little bit. There is a band. The power on them are identical. This over here on the left, lower left, is kurtosis. And in both cases, the values are extremely low. If kurtosis is high, say like 10,000 or 100,000, that means there's man-made RFI. And so that's one thing we're looking for is RFI. Both of them are very near zero. And so there's no RFI in here. And the last test was the noise analysis, where I run a Presto command tool RFI find, and it generates all kinds of data. But this plot summarizes what it finds. And basically, there's no noise. The clone and the EDIS did identical, which is great news because it's considerably cheaper. So on this field test, the clone did very well. And a key thing is, for the first time since we moved into the new building, there's no low frequency harmonic RFI. We talked about that before. We had this RFI that was harmonic, 60 hertz, 120, and on up. It was really a problem, and now there's none. And that's thanks to Ray and Rick and Bill Miller and others that helped with the bonding. So we did have a meeting, and we discussed and planned how to do the grounding and bonding in the control room. And it's mostly done. It's not complete, but it's a vast improvement. So I really appreciate Ray and Bill and Rick and the efforts there to get this bonding nailed down. We did have bonding in the trailer, and now we have it in the new building, and it helps a lot reduce the noise. Oh, and I did want to mention Roger. Roger was when they were installing the fiber. Roger was moving the scintillation experiment. I forgot to mention that we have heard from the University of Texas, and the new location is much better. They're getting significantly better, vastly more data, mainly because the the GPS antenna is no longer in the shadow of the dish. It was kind of right under the dish, and a big chunk of the sky was gone. So it's in a much better position, and they're very happy. It's getting much better data. They used data from our site for their ionospheric scintillation experiments. They're helping students get their PhDs. They published a number of papers on it, so that's working out very well. So the SDR, the Clone Wars, it's a tie. They're both quite good. The problem is, as I said, neither one of the SDRs picked up the upper half of the frequency. If I compare the one we did last Friday with one we did just a year ago, so on the right is another 10-minute collection with the exact same feed, the same sample rate. It was from the trailer. We did much better. And the key difference is, well, we got the upper half of the frequency, and we're missing it here. So that's a main difference. And I'm not sure why. Physically, I do know there were some differences. When I ran it last year, I ran the number of channels. That's the number of frequency channels at 256. When I ran it Friday, I was experimenting. I had it down at 64, and that may not be enough. I may need to increase the number of channels, which will decrease the channel width. I also have been experimenting with the gain. I turned the gain up. I don't think that would cause this problem because the dynamic spectrum looked well, but anyway, those are the differences. So lessons learned from that little test is next time I go down there, I do want to bump up the number of channels back to 256. And then I'll decrease the gain a little bit, and then we'll be exactly duplicating the test that we did a year ago and see how we do. And if it's still a problem, then we'll have to chase that down, but hopefully that'll help. But as I said, I'm very happy with the noise reduction from the bonding. That's a big help. That should help anybody doing anything in there. Just let me say a little bit about the crab. It's the famous supernova remnant from the supernova that was visible in 1054 AD. And it's one of very few, there's not many that do this, but there's three kinds of pulses. There's the main pulse. It's fairly fast at 33 milliseconds. There's interpulse, which is a smaller, weaker pulse, but it always follows the main pulse by 13 milliseconds. And then there's the so-called giant pulse, which can be as much as 3 times the intensity of the main one. So it's a bigger pulse, it's narrower, but it's random or perhaps pseudo-random. It's not certain yet. It does not occur nearly as often as the main pulse. And it's just a result of all these intense magnetic storms on the surface of that neutron star. So the Crab pulsar, the dispersion measure value is about twice of what the first pulsar was. It's a little bit further away, 6,500 light years over in the constellation of Taurus. And it's, like I said before, its period is 33 milliseconds. Its surface magnetism is even higher, 3.8 times 10 to the 12th. Here's the real problem, is it's not near as strong as the plus 54. So at 400 megahertz, it's 550 millijanskis. We've easily detected that before. At 1400, it dropped off considerably more than the average pulsar. The average pulsar still doesn't drop off that much at 1400 megahertz. This one does. And so this is actually below the threshold of anything we've detected. The smallest we've ever detected was 19 millijanskys. So this was a big experiment, a test, and it failed. We ran a 3-hour collection last Friday. On the left is the folding results, and it's just noise. There's no pulsar in there at all. The good news on the right is the time series, and the time series is very clean. Over the years, I put up time series when we had failures, and they would be choppy and bumpy and big jumps in them just from all kinds of noise. So this is showing 8,000 seconds of clean data. So that's great. I'm really pleased with that. Now what I'm trying to do to find the giant pulses, it's called a single pulse search. And the goal is to maximize the signal to noise ratio as a function of dispersion measure. So remember, each pulsar has its own dispersion measure. We know that we're using published values, but what we can do is generate a whole bunch of dispersion measures around that. So we generate a whole bunch of de-dispersed time series. Each one has a slightly different dispersion measure. So I take a step of half of a point of dispersion measure, and I go 11 points above and 11 points below. So there's 22 time series that I generated, each with a little bit different dispersion measure. And then the goal is go and find the peaks. If there's a peak at the correct dispersion measure, then that's a candidate for a giant pulse, a candidate for a single pulse. So on the left is what we had last Friday from DSES. There's no giant pulses in it at all. If you look at this one on the upper right, on the left is the signal noise ratio, and on the right is the dispersion measure. So I'm trying to maximize that, and it's flat. There's no indication anywhere of any good pulse candidate. It just the SNR stays flat. Over here is an example from Green Bank that I ran. So on the right, you see that the signal to noise ratio peaks at the correct value. The correct value is 56.7. So right at the correct value for the dispersion measure, we have a strong peak, which indicates that there's giant pulses there. Then this bottom chart tells you where they are. So the bottom chart along on the x-axis is time, and on the left axis is dispersion measure. So I can go look in each one of these dispersion measure files separately and go look at this time value to see if there's a narrow single pulse there. And that's what's on this chart on the right. So this chart on the right is a time series from that Green Bank data. And as we saw on this one, there's pulses at 10, 40, and 50 seconds. And that's what we have here. Up on the top is its time. So at 10 seconds, at 40 seconds, at 50 seconds, I get very strong, very quick pulses, and those are the giant pulses. Over here on the left, I'm just showing the main pulse and then the interpulse. So the interpulse is smaller. It always trails by the exact same amount. It's just a feature of this magnetic storm. This was data collected at Green Bank using the 20 meter. I used the 20 meter to learn how to do this so that we can do it here at Haswell. I use it for comparisons. It's similar. Our dish is 18.3 meters. This is 20 meters. This is L-band. The big difference is the Green Bank 20 meter has a much better front end. So it's 500 megahertz bandwidth. So they collect a lot more data at once. They do have some RFI, so that these chunks of frequency that are blocked out, that's from local RFI, but still they get a lot more data all at once, and they have a cooled front end, so they have a much lower noise factor. Regardless, I can use this as an estimate to see, well, if they did it in 30 minutes, and we should be able to do it in, say, 3 hours. So that's where the Green Bank data came from. Then some lessons learned on the crab. I don't think we're going to get it at 1420. So I'll talk with Ray, but what I would really like to do is try the 408 feed. So the 408 feed is one we used to have up for detecting pulsars. That would be at 550 millijanskis for this one, and that's something we can detect. I would like to do it before sometime during August, and that's just because of how the crab is moving across the sky. By the end of August, the crab will be setting at 1 or 2 in the afternoon, and if we want to do a 3 or 4 hour collect, we got to start by 9 or 10 in the morning or earlier. So that's why I'd like to swap feeds to the 408 for at least a week or two during August. And then also I want to increase the time resolution to get these giant pulses. The giant pulses are typically 1 to 2 microseconds in duration. And meanwhile, the main pulse sample rate that I used on this collection was 114 microseconds. That number comes from a rule of thumb is you set the sample rate at 1/10 of W50. W50 is the half width, half max of the pulse. Well, in this case, the half max, half width pulse for the crab is 2 milliseconds. So I want to be down in the microsecond range, in the hundreds of microseconds. So the pulse, I'm sorry, the sample rate was good for the main pulse, but not so good for the giant pulses. So I'll probably try it somewhere around 10 microseconds. There's a big trade-off between the file size. If you increase, I'm sorry, if you make TSAMP smaller, you're going to make your file size much bigger. It can grow exponentially, very, very big files. But there's a trade-off between the file size, the amount of dispersion measure you have, and how many channels you have, your channel width. The B210 that we're using, according to the literature, I don't know what reality is, but according to the literature, it can achieve 100 nanosecond resolution with the 10 meg reference source that we're using. If you have another source, let's say we use this donated rubidium source, then the B210 can presumably achieve 16 nanoseconds. But if we're doing something down in that range, we can't do real long collects because it's just overwhelming amount of data. So any questions? That's a quick review on 2 pulsars that we've been working on lately. We do plan to go down there again soon.
I have one comment. The Skynet 20 meter GBT that I believe it has a cryogenic front end. Is that correct?
That's correct. Yes, that's why they get better results.
Yeah, right. And then kind of a dumb question. For the upper frequencies that you were not able to obtain, is there a need to make some kind of a dispersion adjustment for the timing for those upper frequencies?
So we do that. We do adjust for the dispersion. The package that we use is called Presto, and this particular tool is called PrepFold. So Presto PrepFold is the exact same tool that's used at Green Bank and Parks and all the big professional telescope sites. So we're using the same software they do, and it will adjust for the dispersion measure. And there's no difference in processing here. I ran the same software that I ran here. So changing dispersion would not cause that. It's a very good question, but I don't know what's causing that.
Hey, Dan.
Oh, go ahead.
Well, I was just wondering if hello? I was just wondering, Dan, if the giant pulses occur instead of the regular pulses? Are they just giant regular pulses? Or are they in between them or some other timing?
So that's a very good question. And the giant pulses seem to always occur in conjunction with either the main pulse or the inner pulse. They do not, they do not occur out in the other areas. And so what they do is actually some of the energy in this may come from a giant pulse. And so they go find a giant pulse and subtract that. But the giant pulses but they don't always occur. But when they do occur, they occur in conjunction. They occur under this main pulse or the inner pulse.
Or the inner pulse. So he could have a main pulse followed by a giant pulse.
Yeah, it's
Or
crazy.
yeah, that is wild.
Well,
Okay,
and
thanks.
it's
That's
it's
cool.
very poorly understood. You go read the papers and they all say this is poorly understood. We don't know. When a physicist says that, it means they're clueless.
Yep, of course. That's amazing. That's amazing. So,
Yeah.
Is
how
it
about
known if
how about if we can do some kind of ratio metric between 400 and 1200, or 400 and 1400? Could we do it? For example, if you took the 20-meter dish and our dish, and you used the 20-meter dish at 1400, and our dish at 400 megahertz, and look at the same giant pulse in some fashion, you should be able to in some way check those two signals against each other. Am I making it clear? I hope I'm being clear.
Oh, you're being very clear. That would be a really good study. I have not seen that one done, but these giant pulses are similar to the main pulses in that they've recorded giant pulses from, I think, somewhere around like 80 or 90 megahertz all the way up to like 8 gigahertz. So they cover the band.
So you
Is it-
could do the two dishes with the same data set, and somehow compare the same pulses.
Yeah. Well,
Yeah, that would,
we could correlate the time. We could easily correlate the time and say, oh yeah, that's the same pulse. That'd be a good
That-
study. Yeah.
that would be interesting to see.
So, hey, Dan. So the 20-meter
Dan?
dish and that you showed those giant pulses that it detected. So you felt the detective on 18-meter dish, our dish, correct?
Right.
So and gain between, and I'm assuming it's the same frequency, right? 1400 megahertz.
Yeah, except they have 500 megahertz bandwidth compared to our 36. So this shows they collect from 1300 up to 1800, although part of it's blocked out.
Right. I'm trying to wrap the head around like what would be contributing factor, because the gain is it's not different. Now, 18 and 20 meters gain is not significantly different. So it got to be something else, probably the
Well,
bandwidth.
I think it's the gain comes from they get better gain from the cooled front end. They have a much better front end.
The also other thing I thinking, you still using the all the way, so using the RF cable running all the way from the feed
Yes.
to the control room and using the SDR over there, correct?
Yes.
So in their case, they have SDR and all our receive chain right at the feed, correct?
Yes.
That significantly improves the temperature and the noise figure of the
Oh
entire system.
you're right. That reduces their loss a lot just doing that.
Yeah, so one of the, that's one of the experiments in the future. We'll have to think about what we can do to eliminate this, the cable run and have everything at the feed like most of, observatories do.
Yeah. Good idea.
We'll think about this, how we can accomplish that. And also answering your
Dan?
question, I look while you was having this great presentation, so thank you very much for it. I've learned personally a lot of things.
Mhm.
So I look at the bandwidth you mentioned. It's actually 2 megahertz. Definitely no good.
Oh, okay.
Dan, is there, let's see, is there some data that says what the signal strength is at 800 megahertz?
Not directly. So if you look at the ATNF, the Australia Telescope National Facility, they only publish two values, S400 and S1400.
Okay,
But if you go look in the literature, you can find other people doing all kinds of frequencies. And there's a site I go to. It's called the EPN. It's the European Pulsar Network database. I forget its URL, but it's the European Pulsar Network, and they have pulse profiles from many pulsars at many frequencies. I don't remember seeing many around 800 megahertz, and it may just be because of all the interference from television and things like that, but it'd be worth looking.
Some intermediate, some frequency in between 1420 and 400.
Yeah,
And that's a big span. So
yeah.
So, and
somewhere-
one of the things I just thought about, Dan, can you use both B210s to increase the bandwidth? So you can basically split the signal from the feed and use two SDR receivers for each chunk of the spectrum. So you're gonna double.
I believe you can, because I believe there's a way to synchronize the clocks between two B210s. I have not tried it, but I do remember seeing that in the instructions that said if you're running two B210s, then you need to do these settings in GNU Radio to synchronize the clocks. And if the clocks are synchronized, then we can merge the data.
Yeah, I'm pretty sure there is a way, so we can look into that, the doubling the bandwidth.
Dan,
Yeah.
I sent you a note, so some of that's in there.
Okay. The filters, I think the filter, Ray would have to say, but I think the filter that we have on the feed right now it's about 90 megahertz. So we can't actually go over 90, but if we had two B210s together, we could get up to that. And this one I just ran at 36 megahertz because before I start a pulsar, I scan for RFI, and there is a noticeable noise spike around 1400 and 1440. I don't know if they're real or what they are, but I did 36 megahertz between them just to get clean data.
And I have one more question about the feed. So what kind of polarization, what normal polarization for this crop pulsar is? Do you see the difference between, I'm assuming using circular polarization, right? Not linear?
Yeah. I have not seen the difference.
So in a circular polarization, is a right hand or left hand polarization?
I don't remember offhand.
Is it a possibility that, you have a left and a right hand so we can have both a reception, both polarization?
Yeah, the probes we have in this current feed, though, we're using one probe for 1420. We're using the second probe for 1600 to do masers. So this is the same feed we collected masers with last year, doing the 1600 probe in the same feed.
Okay, you don't have a dedicated 1420 feed with the both polarizations, right?
I don't think we do. The best one we have now this is Ray's 1420 feed, and we modified it last year so we could try masers.
Well, the
That's a-
GBT feed is strictly linear. They only have a X and Y axis. They don't have circular on the 20 meter. So whatever detection they're getting is strictly with linear polarizations.
Okay.
I have a question. Could you do observations on the famous UHF channel 37, the 608 megahertz that was left blank for radio astronomy? Is that a possibility?
We don't have a feed for that frequency.
Oh, okay, I see. Just a thought. You were talking between 400. Someone was referencing between 400 and 1400, and I just thought that might be a spot that might not be too bad. I don't know what the adjacent UHF channel and I guess it's only the regular 4 or 5 megahertz bandwidth that you would get there, but so that might be a problem. But
yeah, that's been the tricky part, is finding clean bandwidth. We've done pretty good at 1296. So sometimes when we have the 1296 feed up for moon bounce, we use the same feed for pulsars, and we can get some clean bandwidth there. We get down to 408 megahertz. There's more noise. There's a cell phone tower over near Haswell that's very noisy at 408, so we have to avoid that. But what I found before is there's very few active ham radios around Haswell, and so I use the 420 to 450 ham band and collect pulsars in there.
You don't get any satellite interference for some of those frequencies?
Not 400. We have at 1296. There's some satellites emitting around 1300.
Yeah, I thought there were some ham sets and all that worked on that 400 megahertz band. But anyway, um, is it known whether the giant pulse is? I mean, any theories as to do pulsars have kind of a similar infall from circumstellar disks or similar to like black holes and so forth, where maybe some of that infalling matter is the one that gives the jets an additional power boost? Is there any theoretical explanations for the giant pulse?
Based on what I've seen, the answer is no. They are not similar in that aspect. In fact, neutron stars are shedding material, so they're losing a little bit of material from this magnetic storm. The surface of a neutron star is poorly understood, and it's defined as a crust of neutrons. If you can imagine whatever a crust of neutrons is, then that's what the surface is. And then there's this magnetic storm on that. And it's like, yeah, the giant pulses are a fairly recent discovery, and they're much less understood than the main pulses. But it's just fascinating that we can detect those down there in Haswell.
I'm curious if they might have some relationship maybe to the same FRB type phenomenon.
That I don't know. If you look in the literature, there are some people who write papers on it and say, yeah, FRBs are related to giant pulses. I don't know if that's the case or not.
I see. Anyway, it was a fantastic presentation. I really appreciate that. Thank you.
Yeah, you're welcome.
Okay, very good. Thank you very much. That was pretty illuminating, Dan. Thanks very much. And it's great to see the comparison of the B210s. How much is the clone?
$700,
$700? Huh.
and the real one's $2,300.
I was just thinking about Eve 26, and I think Alex, you were just a quick note there. I think Alex was telling me that we're getting a donation of some equipment. Do you want to just mention that a little bit, Alex?
Yeah, I was going to mention two subjects, since I did not mention, and you put that in the agenda actually. The one is Eve 26, and the one that I did not put at all was Deep Space Network project. So that's coming up too. So, and Paul mentioned that we had some donation, and I did receive that donation. Paul W1 gigahertz sent us the it's a transverter, basically. I'd say converter. It's not transverter, it's converter. Down converter for the DSN, and also he gave us to Deep Space Exploration Society the feed, and the feed is left and right hand polarization. So I have the two ports. So which is kind of, it's actually a commercial feed, so it's a great one for our use. I will compare eventually with the two that I have built for deep space exploration side. So I do have all equipment. I'm waiting for one more down converter to come, and I have a triple system. So I have 3 individual systems and 3 feeds to test. It will be fun to test that. So I try to test it here first using the nearby space object. The cable will receive on my 12-foot dish. If all of this is successful, then we can do experiment on the Voyager 1 from Haswell. That's regarding the deep space network. And for Eve 26, we had initial presentation with the system upgrade for Eve 25. That mainly affects only the power amplifier, because the power amplifier should be capable to generate enough ERP overall with the antenna. And that's going to be 1500 watts. I do have a design. It's just about the funds to obtain to purchase the parts and start building it. The existing Eve 25 system already has 2.4 gigahertz band. So there would be no addition to it unless if we go the different route, as Paul mentioned, using the SDR receiver. And I do have a clone, not B210, but the other clone, which I tested, and I was extremely surprised how clean compared to other SDRs I have, the signal gets. So sometimes something cheaper doesn't mean it's bad. So and Rick proved that too. So I think it's definitely worth the money.
Okay, it's great, Alex. Thanks very much for that update. Moving right along, I do want to talk about the site a little bit here. So let me share the site for you guys. And let's see, where is it here? I think this one here. There. Can you see the picture? Did anybody see the picture? Somebody say something.
Yep.
Yep,
A
I can
lot of
see
gra-
it.
Okay.
lot of grass.
Thank you, thank you. All right, yeah, so last week I sprayed all this stuff here, plus all this stuff here and all this stuff in here with like 3 times the concentration of the bush killer. And as you can see, it's nice and green. This is the second
fertilizer. You spraying fertilizer, Paul?
Yeah, I'm afraid it's good. And there's if you go back around the side here where the tower is, there's some of it is over, well, it's way over my head. It's actually a 6 foot something. And so I'm not sure how we're going to get an antenna in there to put on the tower. It's going to be really hard if we've got to go through that shit. So pardon my expression. But there's some stronger stuff they call DEFCON. Anyway, it's at Home Depot. It's not cheap, but you get a lot of it. You get like 80 gallons. You can make 80 gallons worth of spray. And I might just buy that and try it again with that. But we also have another issue. I don't know if you notice over here on the right-hand side, what these black things are?
Cattle, cows,
Yes. Yeah.
beef jerky.
Beef jerky, exactly. We're wondering where we're going to get our food from. And so here's the other solution. This is
Maybe they can find the rattlesnakes for us.
well, they're eating the bush.
Eat the weeds.
Obviously, whatever it is, they like it.
I saw those cows on County Road 20 when I drove down there Friday. I don't think it's open range, but somebody's just letting them out.
Well, they found our place, and they're
Oh my gosh, there they are.
It's an oasis.
yeah. I mean, they said, let me try this out. Let me taste this one.
You guys
Black
need to-
Angus too.
Maybe we should we
you
could
need-
bring in a herd of goats.
That's what I was going to say. Absolutely.
Yep.
Yeah,
Yep.
they'll
The goats.
trim it closer to the ground.
I didn't see any goats around there, but we got a lot of bull. Anyway,
You can rent those herds of people. You can rent those herds of goats. They'll bring them in and they'll feed for as long as you want them there, and then cut that stuff down to nothing.
Yeah.
I wonder if they like, one hopes they don't like fiber optic cable cover.
Well, I don't know. It's the fiber optics is back here, so hopefully they didn't get any, but I'm not sure where they're going, but they just keep going there. They showed up on my monitor when on the phone. They said there's some movement there. I said, well, who's there? And I see these black things. Anyway,
It looks to me that if Alex can pump something up to about 5,000 watts and we can point the antenna down somewhat, we've got dinner.
exactly.
Yeah.
Well, that's gonna be popcorn then.
Maybe
Anyway,
we should offer them membership.
yeah,
Stick
exactly.
around.
So, and how often, Paul, they come? How often do you see them on the camera?
Well, this is the first time I've seen them. There's more coming. I mean, I don't know how many we've got there. It was probably about 25 head. There's more of them coming along back here. And
Okay.
there's another one coming down the road.
Sure, they're not hanging out in the building.
I hope not. But
I've never seen cattle farms anywhere near that area, except
Yeah,
over
look
the
at
roadway.
look at this. They're like our deck. And and they're going to chew on this is where the GPS line comes in. So
They like your weed killer.
maybe that's it. I don't know.
Salad dressing.
Salad dressing, exactly. But here's more coming, and there's another one coming down the road, and there's another one back here coming across. But they
I'll
keep
be
going this
darned.
direction, so I'm not sure where they're heading.
Somebody might want to know that where they are.
Well, I can't tell whose they are. I mean, there's this guy here. He's got a tag on him, I think. Nope, it's not a tag. It's just a white spot.
Oh boy.
And that was today, Paul?
This is live.
They tag
This is
the
live.
ears. They tag the ears with a QR code so they can
And come down the trail.
count them and stuff.
Yeah, well, anyway, they're carrying on, and they'll.
They're on their way through.
That's a calf behind the other one.
We gotta
all the-
watch. We gotta watch where we step. So, anyway, I just thought I'd give you that update there so you could see what's. And they are eating the stuff here. Look at that. See, they're eating something. There's a baby. Anyway,
Boy, I haven't been weaned yet. That's weird.
yeah, it is weird, but that's our site. So, but I give you a live picture. Okay. Well, anyway, that's our show for tonight. Any other general discussion?
No,
Any-
I was going to say I've got the Tempest weather set, but I have to yet open it up to see if I can make it into a wired set. Roger, did you find out about what variables the National Weather Service wanted?
No, I haven't heard back from them yet. I mean, we just barely started this, looking into this. For anyone that's listening, I at our local amateur radio meeting, we had a speaker from the collaborative hail and rain service. It's a co-op or a cooperative effort with the National Weather Service. And so through him, I'm trying to get a hold of the National Weather Service. And what I'm kind of keeping my fingers crossed on is that maybe they want a weather station in the Haswell area. And if so, they will either could take our data or, up to and including that they would actually establish a weather station using their equipment on our property. I mean, kind of the sky's the limit here. It's all up to them, but I haven't even made the initial contact yet. I'm waiting to hear back from them.
Those weather stations may be reporting on 1600 megahertz.
Well, and that's one thing I mentioned is that we'll have to take a good hard look at it to make sure that we're not introducing RF.
Right.
Yep. Well, if we have fiber, then they can get their data that way.
Bill's not here. I wanted him to send me the two weather setups he got from New Jersey to see if I can just quickly adapt them for our use. But they have wind speed and wind direction only, I think. The Tempest has a lot of stuff, but I'm not too sure how good it is. It's only $300. If I can get it open without having to split any glued joints, I'll see what it might take to put a wire in place of the 900 megahertz signal that they're putting out.
Yeah,
So-
I have a Tempest as well. Don't bother with the bird protector. We have birds that are way too big here, and they just push it down over the over the unit. So it doesn't work.
Yeah,
Paul, you know, the problem isn't uploading the data. It's just that these weather stations typically are report back via, you know, 900 megahertz, whatever, to a
yeah.
base station, and then that is what uploads across the internet. So the
Well,
problem is,
well, the Tempest came with the base.
yep,
The base apparently receives on the 900 and it transmits on 2.4. In other words,
yeah,
it's a wireless connection to the internet and I don't know what you'd call it, a Wi-Fi interconnection to the sensing unit. If I can get a wire to run the 900 megahertz in, then we could probably do something with the 2.4 as well. The idea is to maintain their coding and all that stuff so that it looks just like a Tempest unit by the time it's done. I asked them to send me information on their industrial unit. Their industrial unit involves them as a recipient of the data, and they have to turn it on or something like that. And it turns out that the local people that are selling Tempests and so on, even the Tempest people, don't really know what's in the guts. I think the only people that know are the Chinese, and we'll never find out. We'll never find out what's in the guts. But I'm going to have a look anyway. I'll take it down as far as I can without destroying it, and see if it can be made to run wired. It'll have to be run wired on both ends, so to speak. In other words, it's got to have a
Ethernet connector as well.
Ethernet. Yeah, I'll have to put an Ethernet on in place of the Wi-Fi, but I'm hoping that somehow they'll be kind of cheap replicates of what you can buy from the Chinese for $2.98. I think it's probably the case. I'll have a look anyway. It'll take a
So
while.
this is old information, but I used to have a Davis weather station, and Davis had both a wired and a wireless option. So they actually had a wired
Right.
to the base station. I do not know, I don't remember, or I don't know what the connection was from the base station to the network, whether it was wired or wireless.
Right.
But at least that would make it a wired connection from the weather station itself to the data collection unit.
Yeah. Yeah. Right.
But I don't know if
Well,
that's still available or not.
I still have to look at it. And those units like the Davis and so on, the least expensive I could find was still wireless, and it was running about $1,000, which is just too dang much to be paying for that basic information. I think I could wire up the see that the ones that we already have the information we need, and the tough part's done. The sensors are there, the housings are there, even the chassis is there. If you take the old guts out and put in a Raspberry Pi, it's done. So, you know, and they can be calibrated. You just use your car. You can use your car to calibrate the wind speed and well enough, and you can, then the direction's no real problem at all. So I would like to have a look at those anyway. So if you can catch Bill, he was supposed to send them to me, but and then I'll have a look at them because we won't be using them anyway, one way or another.
Yeah, in the chat, I just pasted another possibility, and this would be a longer term thing to do, would be to build our own weather station. Adafruit, for example, has an anemometer that you can buy. So that's the link that I just
Yeah.
posted there.
Yeah, that we could do that, I guess, but then you have somebody has to take over the maintenance of it and
Yep.
and all that stuff. So it'd be easier if we had a commercial unit. Anyhow, that's enough for now because we're operating on mostly speculation at this point.
But that's the fun part, you know? So,
Yeah, it's the easy part. I gotta
all
take
right,
the
sure.
I gotta take the screws out of the bottom of this thing yet.
All right, well, thank you very much for all your input there, Don and Roger.
Okay,
That's great. And we'll have to look into what we need to do for maybe explore getting a fiber machine, or first thing is going to talk to ES Technologies to see if I can ask them to do us a favor and help us put a piece of fiber connector on. Anyway, thanks guys for all your time tonight, and we'll be posting this on our DSES our YouTube channel, and I'll put a little summary of what we discussed tonight on the DSES Group IO. So,
Roger, I'll stay in touch.
Okay, sounds good.
all
Yep.
right, guys. Have a great night. Thanks again for all your input. Appreciate it.
Thank you.
Bye-bye.
73s.
Good night.